Hi, today I will tell you a little bit about our droop function. To show you the droop function, we have built up a demonstration rig. On this demonstration rig we have two drives for the drive motors, so that those two drives can make torque sharing. And then we have one drive what is a bit bigger than the other ones, and this is the load drive. Inside this demonstration rig we have three motors. We have the two drive motors here. This is the two torque sharing motors. And then we have the load motor down here. All three motors are mechanically connected with the timing belt. All motors have encoder feedback, all three motors. And the two drive motors have also a mechanical brake, so that we can show the hoist mechanical brake function with double feedback. Now you see the rig from the other side, and here you can again see that all three motors are connected with the timing belt. We also have placed some discs here with a pattern on, so that you can really see that the motors are turning. On the control part we can start and stop drive 1 and 2. We can force a release on the brake, and we can make a reverse on the drive motors. We can change the speed. The speed on both drives are connected together, so that the speed reference is always the same. On the load motor we can start and stop, and we can make reverse, and the load drive is in torque mode, so here we can adjust how much torque we will provide on the two drive motors. Now I will start the rig and run them. So I will start with the drive motors and to put them on, turn up the speed, and as you can see when you look here and here, that they are already torque sharing, even though we only have the mechanical losses to carry. Now I will put on the load. So here we start to produce torque and load the two other ones. So now the torque sharing is really nice. The two drive motors have a nominal torque on a little bit above 7 Newton meter, so I can easily put 14 or more than 40 Newton meter, and they will still torque share. So here we have a perfect torque sharing. So now if I want to make redundancy and show the redundancy, I'll take a little bit down, and I will shut down drive number 2, and then you will see that drive number 1 will take all the load. So now drive number 1 is running full load, and drive number 2 is turned off, auto remote coast. If I turn it on again, it will just torque share again. Now I would like to show you full torque. So we put it up to full torque, about 7 Newton meter on both drives, and then, so you can see it's a little bit too much now, I turn it down to 0. And it's still torque sharing. If I turn it up in speed again, it is still torque sharing, even though we have more than 100% torque on the drives. So when we go down, you will see that the torque, when we go down in speed, you will see that the torque is going down also. This is because of the mechanical losses. We only have the mechanical losses if we are rotating, but if we are running 0 speed, you can see that some of the losses are reduced, so we'll go a little bit down in torque. On the droop function we have no communication to tell about the torque on the drives, between the drives. There's the only common signal we have is a start signal and the speed reference. What you see here is only for the MCT10, and what we have here is that we have taken the DC link and put them together here on the demo rig. So now we are running with a new hoist mechanical brake control with double feedback. This means that now we have load on the load drive, and the drive motors are standing still with the mechanical brake closed. So when I open, or when I start them now, they will open the mechanical brake and they will start running. So you can see that they're working very nice up against the load drive. The torque sharing is still running. To demonstrate the double feedback, I will now force the mechanical brake open on drive number 2. And when I now stop the drive, the brake will not close. And what will then happen? Yes, if you look here on drive number 2, with the forced mechanical brake open, it will show up a warning that there's something wrong with the hoist mechanical brake. But the drive will also continue to maintain the torque. So you will always have torque and zero speed on the drive if the mechanical brake is not closing. That means if you don't get the feedback from closed mechanical brake. So now I want to show you how smooth we can start up against almost full torque. That means we have now the load drive to produce a bit more than 10 Newton meter, and the two drive motors, they are have a closed brake, so the motor control doesn't know how much torque they have to produce to start up. But even though they are, so to speak, working in the blind in the beginning, we are making the speed PID a little bit more aggressive, just in a few milliseconds, to be able to catch the load, what the motor control will see in the same period when the brakes are open. I will start, and then you will see that there's no turning back on the backward on the shafts. It will just start in the forward direction and stop again. And it is full control down to zero speed, and now the brakes are coming in. So we have full torque down to zero speed, and then the brakes are coming in. And when we start, it starts to produce a little bit torque, and then we're making the PID a little bit more aggressive, and then we release the brake and we catch the load very smooth.